All right, chapter 9, section 1, rational expressions. Rational, like ratio, right? A ratio is a fraction. That's the base word here, right? Ratio. So rational expression is in simplest form. Simplest form. When its numerator and its denominator have no common factors. None at all. So what are we going to do here? Well, you're going to take these fractions, like, I don't know. We'll do an actual physical example of an easy one. Oh, look at that. Example 1 is one of those. That's what I was thinking in my head. All right, so let's just go with it and fill this in first. Simplify first. You are going to have to divide out any common factors that the numerator and the denominators have. Numerators and the denominators. Before you multiply. All right, looks like the note sheet should have these dashed lines here. I'm not quite sure why it didn't print out on this one. Kind of like these dashed lines down here. All right, example 1. If I have something like 4 divided by 9 times 3 divided by 10, we want to simplify this first. So I'm going to write equals, and I'm going to want one long fraction bar. And I'm going to write these and break these down into their prime factors. 4 is equal to 2 times 2. So I'm going to write it as 2 times 2. Times what's in this numerator? 3. 9 is not prime. It can be broken down to 3 times 3. Both those 3's are prime. 10 is not a prime number. It's a composite number. It can be broken down into 2 times 5. I can't break any of these down anymore. So you factor or break it down to its prime factors, and then we're going to divide out common factors. So you're looking for numerator and denominator pairs, right? Like shoes, a left shoe and a right shoe, except this is going to be upstairs and downstairs. All right, so I look and I say, do I have a 2 in the bottom that I can kick out? Yes, that one there. Do I have another 2 in the bottom that I can kick out? No, it has to stay. Do I have a 3 in the bottom that I can kick out? Yes, that one will take that one out. Folks, you can't have one take out more than one. It's pairs, okay? Pairs, a top and a bottom. These two get divided out because 2 over 2 is 1. And these two get divided out because 3 divided by 3 is 1. Those are ones. They come out. What remains is 2 in the top. And now what remains in the bottom? 3 and 5, and it's multiplication. So this is going to simplify to 2/15. All right, we're going to do this, and we're going to move into doing this with polynomials, okay? So trinomials and such that you're going to have to factor. So the factoring is coming back. And it's going to come back at full force. And it's going to keep moving and going in full force. So make sure that if you're not up on your factoring, that you get some practice. All right. This example here, notice this is x cubed y a times c. So I'm going to put everything in alphabetical order. Alphabetical order. A first, then c, then x, then y. A first, then b, then c squared, then x, then y to the 4th. It just helps you to see the letters that are alike on top of one another. All right, now I'm going to look and say, oh, well, look, I have a pair of A's. This A will divide out that A. I don't have any B's. So the B has to stay, and it has to stay in the denominator. The c's. Look at the c's here. I've got a c and a c squared. Remember when we worked with exponents, one of these c's will kick out one and only one of those, leaving me with one left. That also has to stay in the denominator. The x's, and they are here, visually. I'll give you a visual. All right, 3x's in the top, 1 in the bottom. Well, guess what? The bottom one's going to kick out one of these, leaving me with 2 left up top. The y's. I've got y's in the top and the bottom. I have 1 in the top, 4 in the bottom. This 1 will lower this one by 1, leaving me with 3 in the bottom. Now notice my original problem, each base was not occurring just one time, so I had to divide out common factors. Look at my new and improved finished final product. I only have one x, one b, one c, one y, right? B, c, and y are in the denominator only, x is in the numerator only. So this is my simplified version. Of course, we really should talk about restrictions here, because anytime you have letters in the denominator, you need to include denominator restrictions. So the only value that a, b, c, x, and y cannot equal is 0, right? So a can't be 0, b can't be 0, c can't be 0, x can't be 0, and y can't be 0. And yes, while I realize there's no more a in the denominator and there's no more x in the denominator, they were in the denominator here, and so you must include them as restrictions, right? There are restrictions because division by 0 is undefined. All right, let's look at example 3. Now be careful with these. This is a quantity, and I recommend that you group it, because you're going to try to divide out c's and you can't do that, okay? So I'm going to rewrite this, what this means. This means quantity a plus c times d divided by b times c. Well, guess what? There are no common factors. I know you might think those c's can get divided out, but they can't. They cannot. So we're going to write here in our notes, there are no common factors. And remember to use parentheses around quantities. Right? Anytime you see addition or subtraction between two or more things, you want to group that right away so that you're not tempted to divide those out. You cannot divide them out. Division and addition are not inverses. Multiplication and division are inverses. We could only divide out up here because what was happening between all of the terms was multiplication. What's happening between these terms is not, right? That's addition. So be careful of that. All right, so since there's no common factors, that's my final answer. Of course, B can't be 0, and C also can't be 0. That would be my restrictions. All right, if you have questions on that, please let me know. We will go on to page 2. To example 4. You know, I highly recommend that this is a blend of examples 1 and 2. So why don't you pause the video and try to do this one on your own. All right, I'm hoping that you at least pause it to set that part up. Notice I took 14 and broke it down into 2 times 7 into 15 into 3 times 5. X cubed times x is x to the power of 4. 9 can be broken down into 3 times 3, the 4 into 2 times 2. The y times y squared is y cubed. Notice in terms of variables, I don't have any like variables both in the numerator and the denominator at the same time, but I do have some integers that are in common. So I look at this and I say, all right, I'm going to start with the 2. Is there a 2 in the downstairs? Yes. I could take out one pair, only one pair. Is there a 7? Nope. Is there a 3? Yes. I could take only one. Is there a 5? No. Is there an X? No. So I'm finished dividing out common factors. Final answer here is you then have to multiply these, right? 7 times 5 is 35, x to the power of 4, divided by 3 times 2, 6, y to the power of 3. If I'm listing my restrictions, the only restriction here is y can't be 0. It's the only variable in the denominator. All right. Example 5, that's a division one. Now, if you remember from the quarterly exam and the quick lesson that you received to be able to do those problems on the quarterly is, you change the division to multiplication, right? Change to multiplication, and then you flip this fraction. This is the philosophy behind it, so I'll do this quickly in the notes. If I have something like 2/3 divided by 1/2, well, I don't know how many times a half goes into 2/3. That's just crazy talk. But I know I can manipulate this. I can make this denominator fraction become a 1 if I multiply by the reciprocal. And if I multiply by the reciprocal on the bottom, then I have to do the same thing up top, right? Because 2/1 divided by 2/1 is 1. So this thing right here is really multiplying by a 1, if you see it, right? 2/1 divided by 2/1. That allows me to free up the denominator and make it become a 1. And now I've got 2/3 times 2/1. But now if we look at my original problem, a fraction divided by the fraction is the same thing as changing the division to multiplication and flipping or inverting the divisor. Okay? So memorize that. When you see division, you're going to change it and you're going to flip this. All right, well, let's do the flip first. 5a cubed b to the 4th divided by 3b to the 7. Multiply. The 9b cubed comes up top. The 25, a to the 5th b goes to the bottom. All I did was change the division to multiplication and inverted the divisor. Because what I'm really doing when I do that is this. Okay, I'm really doing this whole entire thing right here without showing all that work. Okay. Now let's simplify and break this down. All right, 5 is prime. I'm going to keep it a 5. The 9, I'm going to move it out here and do 3 times 3. A's and B's. Well, I got 3 A's. I got 4 B's and 3 more B's, or 7 altogether. So I have everything. I believe I collected everything. All right, I'm going to break down, well, the 3 is prime. I'm going to break the 25 down into 5 times 5. And I've got a to the 5th, b to the 8th. All right, now I'm looking for numerator-denominator pairs. This 5 will take out that 1 5, 1 and only 1. This 3 will take out that 3, 1 and only 1. This 3, well, there are no more 3's to be taken out. The A's, 3 of these kick out 3 of those, leaving me with 2 left below. 7 of these kick out 7 of those, leaving me with 1 below. And now I'm going to clean this up and simplify it. Equals, well, what remains in the top? 3. What remains in the bottom? 5a squared b. Final simplified answer. I should give my denominator restrictions. Notice there was an a and the b in the denominator. In the original problem, there were only b's. But when I flipped that, now an a came down. So a can't be 0, b can't be 0. All right, so if you have questions, please let me know so I can help you. Remember, you have to break everything down to its prime factors. Have a great day.